Hi, I Aziz welcome you to CoedMaster, and in this video I am going to talk about this problem. So let's get started. So the problem is given as you are given a set of 3 characters and you have to find power set of this given set. So let's first understand what is mean by power set. So power set is a set of subset. So let's say you have a set of 3 characters, then how many subsets are there? So the first subset is a blank set, then one subset is A, one is B, one is C, one is AB, one is AC, one is BC and one is ABC. And if we put all the subset in a set, then we call it power set. So let's say if a string is ABC, the size of a string is 3, then there are 8 subset of this string are possible. One is the blank subset, or we can say empty subset, then A, B, C, AB, BC, AC and ABC. So let's pause this video and think about a solution to solve this problem. So we have 3 approaches to solve this problem. One is the recursive way to solve this problem, and recursive approach takes big of 2n time and big of n space to solve this problem. The second option is iterative solution, and this solution take big of n into 2 to the power n times and big of 1 space to solve this problem. And the last and the efficient way to solve this problem is using bit mask, and this approach also takes n into 2 to the power n time and big of 1 space to solve this problem. So before we understand mask in technical term, let's talk about the real life analogy of mask. So we wear mask, right? And why we wear mask? So that we can protect our face or no one else can see our face, right? Now let's apply this same analogy in bit mask also. So let's say I have a mobile number and last 3 digits of my mobile number is 123. So if I want to store this 123, then I have to create a set, and in that set I have to enter 1, 2 and 3. So can we have a better way to store these numbers? Yes, we do have. And this is where bit mask come into picture. So how we do it? Let's see. So here I have 1, 2, 3. If I somehow find a number whose first, second and third bit is set, then we are done, right? So this is a number whose first, second and third bit is set, and this number is equivalent to 14 in decimal, right? So here I would say that the binary representation of 14 is simply putting a mask over last 3 digits of a mobile number, right? So when you see 14, you cannot figure out that this 14 is representing 1, 2, 3. Only us as a developer can figure out that this 14 is representing number 1, 2, 3. It means, and number 14 means first bit is set, second bit is set and third bit is set. So this is why we call it bit masking. So the idea is simple. We are using bits to mask something, and that could be anything. So using this approach, now we do not have to store a set of 1, 2, 3. Instead, we can only store 14. And by looking at 14, we can easily figure out that what are the last 3 digits of mobile number, right? So in order to find power set of a given set, we are simply going to use this concept of bit masking. So let's say we have a set S of 3 elements A, B, C, and the size of set is 3. So now the question is, how many subsets are possible? If we have 3 characters, then how many subsets are possible? So it is equal to 2 to the power n, and 2 to the power n is equal to 2 to the power 3, that is equal to 8. It means there are 8 subset possibles from 0 to 7. Now how we use bit masking here? Let's see. So let's consider the binary representation of a number from 0 to 7. Why 0 to 7? Because 8 subsets are possible from 0 to 7. Now let's consider all the binary representation of number 0 to 7. So if you observe all the binary representation, you would see that in 0 all bits are unset, in 1 bit is set, in 2 second bit is set, in 3 2 bit is set. So I have taken 3 bits here. Why? Because number 7 can be represented by 3 bits only. See, look at this here. So we only need 3 bits to represent number. So as we have numbers from 0 to 7, so 3 bits are more than enough. So now if we associate this first bit with A and second with B and third with C, then we can see that we are having a subset. How? If all the bit is unset, it means we have blank subset. If first bit is set, we have subset with A. If second bit is set, we have subset with B. If first and second bit is set, it means we have subset with A and B, so on and so forth. So here the binary representation of a number is acting as a bit mask over the subset. So it's simply a mask of subset. So the idea is simple. So now we can use this idea to solve this problem. So the idea is simple. First we traverse from 0 to 7 and we consider binary representation of all the numbers from 0 to 7. And then we traverse all the bits of numbers. Right? And while traversing bits, we simply check if the bit is set or not. If bit is set, we simply print a character corresponding to that bit. Alright, so let's move on to see the implementation of this approach. So this is the implementation of the approach discussed above. So here we have a function powerset, and this function is taking string as s. So we are first getting the length of the string and stored in n, and then we simply calculate how many subsets are possible by doing 2 to the power n. So we can do 1 left shift n, right? Because we can calculate power of 2 by using left shift operator. And then we are simply running a loop from 0 to less than equal to subset, means 0 to 7. And after that we are simply printing open bracket, and then we are running a loop from 0 to n. And in this case, and in case of 3 character, we have n is equal to 3. So we are running inner loop from 0 to n. It means 3 times we are running, because we want to check 3 bits. That's why we are running 3 times. And in each iteration we are checking if the bit is set or not. So in each iteration this loop runs 3 times. So first we check 0th bit, then we check first bit, and then we check second bit. And if the bit is set, then obviously that number is not equal to 0, and we enter into this if statement and we print the character corresponding to that bit. And after this for loop we simply close the bracket, and after that we simply print a line. So let's do the dry run of this code and see how it works. So in case of s equal to abc, n is 3, the size of a string is 3. So how many subsets are possible? 2 to the power n, that is equal to 8, means 0 to 7. So in first iteration our number is 0, 0. So the binary representation of number is 0. So we are not going to, so this loop is not going to run because all bits are unset. In next iteration we have 1. So this loop is going to run 1 time, and the first bit is set. That's why we get a subset with a. In next iteration the number is 2 and only 1 bit is set, that is second bit. So we get 2 as a subset. So we get b in our subset. In next iteration the I becomes 3, and in 3 there are 2 set bits. So we get a and b in subset, and we follow this process continuously till I is less than equal to subset. So we get all the subset printed on the screen. So this is how this function is going to work. Now talking about the time complexity of this function, the outer loop runs 2 to the power n times. It means 0 to 7. And the inner loop runs n times. And n is what? N is 3. It means in each iteration it runs 3 times. So the overall time complexity of this function is going to be theta of 2n into n. Clear? Okay. So let's have a quick recap of what we have learned so far. So first we are given a set and we have to find power set of that set. So we learned what is meant by power set. Then we learned about what is meant by masking. And then we saw that how to use bit masking to print all the subset of a given set. And we call it power set. So I hope now you have good understanding of how to print subset or power set of a given set. This is it for this video. Thanks for watching. See you in the next video.